Bienvenidos, Hushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course from the Spring 2021 semester. This is the CCNP ENCOR version 8 course using the Cisco Networking Academy curriculum. In this activity, we're going to be taking our first look at external BGP or eBGP. We're also going to be taking a look at a number of resources that are available to you. I'm going to show you how to log on to route servers at the University of Oregon and in other locations where you can then take a look at the global BGP routing table that's actually running around the world. We're going to be talking about IGPs versus BGP. We're going to be talking about the path attributes like next hop or AS path. And we're going to be defining what NLRI is really all about, that network layer reachability information. I'm going to be pointing you to additional resources that you can use to really master the Border Gateway Protocol. And let's start with one of those first resources that I always recommend, and that is the RFC. And this gives you sort of a historical snapshot of the RFC standard for BGP. Now, this is RFC 4271. You can see there was an older version of the RFC, which this version has obsoleted. And one of the first things you'll notice is right down here in the abstract, that term that I mentioned, that network layer reachability information. And really, NLRI is sort of a fancy way to say routing information or prefixes that are out there. And they're exchanged between autonomous systems or ASs. Now, we've already talked about autonomous systems, and remember, that's an entity in general that is under someone's control. Specifically, we're thinking it's in your control, that you are in control of the autonomous system. So let's go ahead and dive in and take a look at the activity we're going to be working on, and then we're going to build the conversation out from there. And so here you can see we have 3 autonomous systems. We've got the Acme network over here, Autonomous System 65001. We have the Transit Autonomous System. And again, transit ASs are typically service provider ASs. In a transit autonomous system, if you think about it, the definition makes sense, right? It's where your traffic from Acme's network is going to transit in order to reach some other location. In other words, you would not want Acme's network, your company's network, being a transit AS for internet traffic. That could overwhelm your network. And so service provider networks are typically transit autonomous systems. They're there so that your traffic can transit through their autonomous system to reach some other destination. And in this activity, we're going to be trying to reach the other company network, which is autonomous system number 65002. Now, a quick note on these autonomous system numbers. Keep in mind that this range that you're looking at here, this 65,000 range, that these are considered to be private autonomous system numbers. Now, there's nothing wrong with using private autonomous system numbers for lab configurations or for configurations where you're simply setting things up and a private AS is going to suffice. Now, if we're talking about routing traffic on the global internet, that is where private autonomous systems are not going to work for you. And you're going to need some sort of a public autonomous system number. And there's multiple ways that service providers can peer with you using a private autonomous system number, right? So between these 2 autonomous systems, right, your company Acme and the service provider, we can peer using private autonomous system numbers. And then what the internet service provider may do to Acme's AS is simply override that autonomous system number. In fact, they can replace that autonomous system number with their own. And excuse me, again, that's totally legitimate, and they can do that because it allows them to in an easier fashion to track the customer connections that they may have and not to use their publicly routable autonomous system number. And again, there's multiple ways to do these peerings, and this is completely legitimate to do it like this. And again, this is an example, so they're going to be showing you these private autonomous system numbers. All right, so here's our addressing table. Let's dive in here. So from ISP entry 1, verify that the ISP has provided the IP reachability information through its network by pinging the 1119, which is the IP address of the ISP entry 2 serial 000 interface. And so let's go ahead and pull up these routers right now. And on ISP entry 1, let's go from user exec to privilege exec, and let's try to ping the 1.1.1.9. And as you can see, we've got reachability information there. So from any device inside the Acme network, ping the other company server at 172.16.10.2. Now these pings should fail, so let's go ahead and just pull it up here real quickly. We'll drop this down because we'll use this guy later. And let's go ahead and say ping 172.16.10.2. And we should see that these pings fail and we get a destination unreachable. And the reply is coming back from the 192.168.0.1. So who do you think 192.168.0.1 is in that conversation of these ping packets failing, right? Well, our guess, if it's the default gateway for PC0, and we can easily check that. I could say ipconfig, but I'm just going to drop over here to the GUI. You can see right here, 192.168.0.1. That is, in fact, the default gateway. My guess is it's going to be the gig interface here, show IP interface brief, or one of the gig interfaces, and it is. It's gigabit Ethernet 00. And so why is this router saying it has no idea how to get to the other company network and autonomous system 65002? Could it be that in the routing table for Acme's router, I have no route to get there? And the gateway of last resort is not set. In other words, I don't have a default route. If I had a default route configured, pointing to ISP entry 1, the router ISP entry 1 here, then this would probably work. But I don't have a default route configured. We don't have BGP configured so that I can't get any routing information from the any BGP NLRI, Network Layer Reachability Information. I can't get that from the ISP because we're not running BGP and we have no BGP neighbor relationship established. Now, we know that that's the problem. Let's do this last. It says configure Acme 1 to become an eBGP peer with ISP entry 1. Acme has autonomous system number 65001, and the ISP is using AS number 65003. And we can see that information here. So use 1111 as the neighbor IP address and add the Acme internal network 192.168.00.24 to BGP. Now, a few things here. These are some of the significant differences between IGPs and BGP. Remember, with the IGPs, EIGRP, OSPF, we were using multicast. And what we were doing was we would configure the interface on the router, and then as soon as we enabled the OSPF process on that interface, it would start sending those OSPF hellos, right? And EIGRP hellos that would go out onto the segment or over a point-to-point interface looking for other OSPF or EIGRP speakers. With BGP, that is not how it's done. BGP leverages TCP. So in other words, the creators of BGP, Yakov Rector and Kirk Lougheed, and hopefully I'm saying those correctly, the pronunciation there, they got together, and when they were sitting down at a restaurant, actually, on the back of 3 napkins, they actually sketched out the rudimentary implementation of what BGP would look like, and they decided we don't need to create a brand new protocol for BGP to use in terms of neighbor discovery and the maintenance and upkeep of those neighbor relationships. We'll just use TCP, the Transmission Control Protocol. And in fact, that 3 napkins protocol, or they call it the 3 napkins protocol sometimes, because here are, and again, this is paper, these aren't the actual napkins, but here are the sketches that they did in terms of what BGP might look like. Because at the time, there was another routing protocol called EGP. And this becomes confusing because we say IGP to represent interior gateway routing protocols. The IGPs are OSPF, RIP, IS to IS, EIGRP. Those are your IGPs. Then you have the EGPs, the exterior gateway protocols, right? And the EGPs, there's really only one. It's BGP. But back in the 80s, there was this other protocol, not a classification EGP. There was actually a protocol with the name EGP. And that is really what led to this conversation about BGP. And it was the fact that EGP, the protocol, just simply couldn't scale. It just could not do what was going to be needed. And again, you can see down here, Cisco's Kirk Lougheed and IBM's Yakov Rector. And these individuals are titans in the BGP sort of realm. Again, it doesn't get any better than primary source material. And if you remember from the RFC that we looked at, who is one of the main authors? It's Yakov Rector. And so when we talk about primary source information, me telling you about BGP is not primary source, right? Secondary at best, maybe tertiary. But again, I'm not a primary source. Yakov Rector, Tony Lee is another individual who were involved in the writing of this massive RFC on BGP, right? And you can see here are some of those BGP path attributes that we're talking about. The origin path attribute, the AS path attribute, next hop, multi-exit discriminator, or MED, local preference, atomic aggregator, and others, right? And so this is the place to come for primary source material. Now, I'm going to give you some other resources here, right? Because again, as I said, I see myself as a guide, not sitting here showing you, oh, look at all these cool BGP things I know how to do. It's about getting you the references and the resources you need in order to build your BGP skill set. So Tony Lee, it doesn't get much better than this right here. And this is 39 minutes of BGP gold. The gentleman in the lower left, that is Tony Lee. This is Yvonne Sharp, and she is the, I don't want to say the owner of Network Code, but one of the founders of Network Collective. This is Don Sharp over here to the right, and this in the lower right-hand corner is Russ White. And again, Russ White is another one of those titans in the networking industry when it comes to routing protocols. And so this is a 39-minute interview with Tony Lee about the history of BGP. And basically, it's all about BGP. So again, if you Google history of networking Tony Lee, or history of networking Tony Lee, history of BGP, or come to the Network Collective. The Network Collective is loaded with interviews from primary source individuals. They actually have one with Radia Perlman on Spanning Tree. You know, it doesn't get any better than that when you get these primary source individuals, the individuals who were involved with the creation of the protocols that are literally powering not just the internet in the case of BGP, but all of your layer 2 infrastructure, right? So again, this is an amazing resource in addition to RFC 4271. So again, I'm going to segue in and out of different things to make sure I provide you with as much information as I possibly can. Because again, the official certification guide is great, but if you really want to master BGP, and if it's your craft, right? If you're going to say that, hey, I'm a network engineer, this is my craft, you're going to want to master BGP. All right, so let's configure Acme 1, and we have Acme 1 up here, to become an eBGP peer with ISP entry 1. So we're going to, in a global config, I'm going to say do show run section router BGP. And you can see that we don't have a BGP configuration. Excuse me. At this time. So how do I do that? Well, just like I say router OSPF, I say router BGP, and I'm going to do a question mark because here's where we're going to put in the autonomous system number. Now, just like you would say router EIGRP, excuse me, and put in the autonomous system number for EIGRP or router OSPF and the process ID for OSPF, we would do the same thing here. And so our autonomous system number, which is displayed above, is 65001. So we've got that in there. The AS is using autonomous system number 65003. So let's see which options we have here. Now this is pretty cool because they do give us a few of the options that we might be interested in here. If I say BGP, you can see that I can set my router ID. Excuse me. I can log neighbor changes, right? So sort of a logging enhancement that's going to log any changes that are seen on the router. I can say BGP router ID. Again, these things not required as part of this activity, but we're going to go ahead and do them anyway. And real quickly here, let me check and see, do show IP interface brief. What is that serial interface? So the serial interface is 1.1.1.2. And let's go ahead and set our BGP router ID to be 1.1.1.2. Now, the router ID, again, BGP is an eGP protocol, right? It's classified as an exterior gateway protocol, not an interior gateway routing protocol. So if I was to try to do the little trick 0001 for the router ID, I could do that, but we want it to be identifiable by something other than that 0001. So I'm going to use that, the IP address that we share between Acme 1 and ISP 1. So there's some other things that you can set that are always a good idea to set. Now the router IDs with eBGP, not as important as with iBGP or internal BGP. So external BGP, yeah, set the router ID. It's always a good idea to hard code that router ID. When we're talking about iBGP, that's when we actually may need to dig in and look at different output to discover which router we're actually looking at. And so again, always a good idea, hard code that router ID. So now looking over here, we're going to go ahead and use for our neighbor statement, right? Now there's two statements that we're going to be concerned about with this introductory activity here, and that is this neighbor statement and then the network statement. And so just like the network statement with EIGRP or with OSPF, this is how we will originate, advertise network layer reachability information, specifically that 192.168.0 network that we're very interested in, that they're actually going to have us originate. And that's very, very important. And so remember, the network statement is how we originate NLRI. Well, how do I discover neighbors? Well, remember, it's not neighbor discovery. We are actually going to specifically and have to specifically indicate the neighbor with which we want to speak BGP, and in this case, eBGP. Who is it that we want to try to establish a neighbor relationship with? And so I would say neighbor 1111, because again, that's on this directly connected link right here And then I have to put in the remote autonomous system number. So remote AS, and you can see this is where I put in the other autonomous system number, the other autonomous systems number, right? What are they using? And this is what differentiates an eBGP connection when the autonomous system number is different than mine, me being Acme, is different from mine. So their, right, the Transit AS, their autonomous system number is 65003. My autonomous system number, Acme network, is 65001. This will be an external BGP adjacency or BGP neighbor relationship because the autonomous system numbers are different. And you can see BGP, we get a notification syslog message here that the adjacency changed. My adjacency with neighbor 1111 is up. But there's a lot that went on here that we didn't see. And so I've got BGP running, and I already have a Wireshark packet capture between router 11 and router 8. And let's take a look. Remember, BGP leverages which upper layer protocol, which layer 4 protocol? It's TCP, right? Because again, TCP has keep alives, or we can do keep alives with TCP, and we do with BGP. Every 60 seconds, you're going to see a keep alive message go out. But take a look what happens here. Router 11 on this random high port 55285 sends a TCP packet to port 179. And then you can see router 8 responds back to router 11, right? Coming from port 179 because we're looking at router 8 as the server here. It's accepting that inbound connection that's coming in from router 11 on a random high. And we get an acknowledgement. And then you get another exchange of packets. And now we have a SYN packet that goes out, right? Because this is from a previous, I did a reset on the relationship. So this is the new router 8 now sending out from its random high, right, to port 179, a SYN, right? And then we get a reset and an ACK, and then you get a SYN and a reset and an ACK. And then if we come down here, you can see a SYN and a reset and an ACK. But then we get this conversation that takes place between router 8. We get a SYN ACK, and an ACK. And what do those three things represent? And this kind of takes you back to networking 101. SYN, SYNAC, ACK. It's the TCP three-way handshake. And so once we have a successful TCP three-way handshake, SYN, SYNAC, ACK, between these two routers, running BGP over TCP, we get the first BGP message that we're interested in. And that is the BGP open message. And we can see it here. So let's take a look at what that open message looks like. You can see there's my BGP router ID, the BGP identifier 8888. Any optional parameters, right? So some capabilities that are being exchanged. I'm a BGP speaker, but what capabilities do I support? Well, I can support multi-protocol extensions, IPv4, IPv6. And let's come down and take a look at route refresh capability. So I can support the refreshing of routing information, support for 4-octet AS numbers. So remember, we looked at those autonomous system numbers on the CLI and saw that there's only 65,535. So you might be asking yourself, well, I mean, we're going to run out of those just like IPv4 addresses, right? And you are absolutely right. And that is why they came up with this 4-octet AS number, or dot notation, as you will sometimes hear it referred to. And so router 8 is telling router 11, hey, here are some of the capabilities that I support. And then take a look. Router 11 is now telling router 8, and you can see these messages are being acknowledged here, that, hey, oops, sorry, I wanted that one, that, hey, here are my capabilities in the open message. And then you can see we've got some keep alive messages, and then we get this update message. And what might be in this update message? Well, it's network layer reachability information, because router 8 and router 11 are each configured to originate or advertise their loopback addresses. And again, this is just kind of like pretending, oh, hey, look, we're originating this network information and I'm using a loopback address. And so router 8 sends out this update message and says, hey, here is the network layer reachability information for this prefix /32, and the prefix is 8888. So here is the NLRI, the network layer reachability information. If you need to get there, then come to me. And you can see that it just states that it's an update message, right? And you can see here, update message is type 2, open is type 1, and then you'll find out there's keep alives, there's notifications, right? So there's other messages that we might see. And in fact, there's the keep alive, right? You see this little keep alive message here, which really isn't after the 60-second mark right now. And so then we get an update from router 11, right? And not much information here. And then you get this acknowledgement, right? But again, the port is 179. Another easier way to see that is if you're on the command line and you simply say, and that was not expected. So we'll come over here to router 8. There should be no user ID there. So we'll come over here to router 8 and we'll just simply say show TCP brief. And this will show the TCP connections for this router. And we can easily see there is the port number 179. And remember, BGP is running over port 179. And here we'll look at it like this, that the server, the TCP server for BGP is router 11 because router 8 is using this random high port number to connect to port number 179. And yes, there is a process that the higher router ID is going to be the server and the lower router ID is, you know, when they both send those TCP synchronize packets, they've got to figure out, well, you know, who's going to be the server, who's going to be the client. And so that's how that process takes place. All right, so back to the activity. So our neighbor adjacency is up. The next thing we need to do is originate that NLRI for the 192.0.0.0/24. Now, this is very, very important right here. And this is typically where learners will get tripped up the quickest with BGP. Again, configuring a BGP adjacency is extremely simple. Neighbor, whatever the neighbor's IP address is, and their remote autonomous system number. Boom, the adjacency's up. So you might think, well, hey, I've configured BGP. Well, this is, as we start to peel back the layers of the onion, you're going to start to cry a little bit more and more because it tends to get a little more complicated when we're starting to work with real BGP scenarios. So we've got the network statement. So I'm going to say 192.168.0.0. Now, it's a /24, right? The classful mask for a 192.168 is a /24 for a Class C address. If that's the case, I can hit enter right now. I don't have to configure the mask, right? So it's not a wildcard mask, it's a subnet mask. And if the network that you are originating is already at the classful boundary, meaning it is a /24, or it is a /16, or it is a /8, you don't have to put that mask piece of this command. So I could just as easily hit enter here. Now, this is packet tracer, so my guess is it's not going to do what we think it's going to do. So I'm going to go ahead and put the whole command in here with the mask, even though that is redundant. What I just did right there from a BGP perspective is redundant, right? So if I say network 192.168.0.0, which is a Class C address, which is a /24, I don't have to put that the mask is a /24, right? It's assumed that that's what it is if I don't put mask and then the 255.255.255.0. Now, you'll notice that Packet Tracer gave us points, but let's take a step back over here to router 8. And this is going to be real disappointing here on router 11 if it wants a username, and I don't think it's admin password. And this was not supposed to happen. So here's what we're going to do. Let's see, what else do we have? So we'll just stick with router 8. And not ideal, but again, we'll stick with router 8 on this. So let's go into global config. I'm going to say router BGP 8, because that is the autonomous system number I'm using for router 8, again, just to keep it simple. And if I was to say network 192.168.1.4 and not put the mask statement, right? Now the mask on that, if it was a /30 that I was trying to advertise, that's what it would look like. And for that use case right there, to advertise this /30 network, I have to put the mask on here. I have to put mask and then what the actual subnet mask is in 32-bit dotted decimal notation, or else it will not advertise that. If I hit enter right there, and I say do show run section router BGP, that is exactly what it puts in there. And right now, what is implied, and think of it like this, what's implied when I use an address that is a Class C address, or if it was a Class B 172.16, whatever the case may be, BGP looks at this, iOS looks at this and says, oh, so that's a Class C, so then implicitly right here, it's thinking mask 255, 255, 255, 0. And that is not the actual mask of this network segment. So like if I was simulating the network segment and said loopback 192, IP address 192.168.1.5, and I said 255, 255, 255, 252, right? So this IP falls within that /30, right? Because .5 and .6 are going to be our two usable, and .7 is going to be the broadcast address, and this is the network ID. We're going to have a problem, right? It's not going to advertise it because that is not the actual subnet mask length, right? The implied /24 here is not what the real subnet mask length is. And so in order to fix that statement and to get that network advertised, I would actually need to say, and I think let's see if we can do get around the no. I'll say network 192.168.1.4 and then say mask 255, 255, 255, 252. So a quick do show run. We should only see that. We left it in there, so I'm going to get rid of it. No network. I was hoping it would override that statement, and it didn't, but that's okay. And let's see, did we delete both statements there? All right, we didn't. And so that would be the correct way to do this, right? You have to have the mask on there. If the network doesn't fall on the classful boundary, then you need to do the mask, right? Very, very important. All right, so we've added this in here with the mask, and we got a few points for that, and it says, for any device inside the Acme network, ping the other company internal server again. So let's pull this back up. Let's go to the command prompt, and let's go ahead and say ping, and let's hit the up arrow, 172.16.10.2. And you can see what the problem is here, right? So what did we do? We configured, and let's say end here, and let's save my config. We configured the BGP peering between Acme and ISP entry 1. But let's say show IP route. And do you see any BGP learned information in here? Well, yeah, I see these two /30s, which I can almost guarantee are going to be here and here, right? The 1114 and the 1118 are probably these transit network segments. Could be. Right? Could be. And I'm just thinking that because here I'm 1111 and the ISP is 1112, or it's the other way around. Yeah, the ISP is 1111 and I am 1112. So it looks like /30 here, /30 here, and a /30 here. And that's the information I'm seeing. Am I seeing any routing information that would help me get to the 172.16.10.2 or the 172.16.10/24 network, right? No, I'm not seeing any of that information. Now, my guess is it's because other company hasn't advertised that information. What could fix this though? I could configure a static route here, right? Because I am advertising my 192 network. This is being advertised in the BGP. If I said show IP BGP summary, right, we can see that I have a neighbor relationship. We can see, and again, this is a packet tracer where you see this 4 here, right? And it says prefixes received. Now, if you see anything other than a number here, anything other than a number in the state prefix received column means that you do not have a BGP adjacency with whoever this neighbor is. Anything other than a number here means you do not have an adjacency, right? You could see weight. There's all kinds of things that you could see in terms of the state that you're going to end up looking at. I could say idle, active. You may see established, right? But until you see a number here, you don't have a BGP adjacency. And so we're not seeing the routing information we need from BGP. So how could I fix it? Again, I could put a default static route on here saying send all traffic out here. And this is a good point to talk about. Do I have to use BGP? And the answer is no, you absolutely do not have to use BGP. Now, how many ways out of this network, out of this autonomous system, how many ways can I get out? Yeah, I have one way out of this network to get to my ISP. And so I know why that we're doing this activity, right? So that we can learn the basics of eBGP configuration and understanding a few of the commands. But if there's only one way out of the network, that's what you would do. You wouldn't configure a BGP peering when all you would need to do is a default static route. I'll just say DSR, default static route that says, if I don't know where to go, throw it out to the ISP. That's what you would do here, right? If you're never going to have a second connection and you don't need policy to control which connections are going to be used, then just do a default static route. So this activity is great because it allows that conversation to take place. Well, would I need to run BGP here? And the answer is no. Do I need all of these longer, more specific matches learned via BGP to get to the 172.16.10? No, because I only have one way to get to that network. So the default static route from a configuration perspective would be the way that you would approach this. Now, if maybe down the road, you're thinking that, hey, we love ISP, the transit AS, or this provider. We love this provider. We're going to do another connection to a different router, right? Then maybe we've got this primary backup. And again, still you might be able to deal with this with floating static routes. Where BGP really comes into play is when we've got, and I didn't want that there, we have this other ISP down here, and this other ISP has a couple routers, and it's transit AS, and we'll just say 6500, what we're not using here, 4. And we decide, hey, we want to connect up to this other AS down here, this other provider. You know, maybe this is Comcast and maybe this is Verizon or AT&T, Hurricane Electric, take your choice. And they connect up over here to other company as well. Now we need policy. We need BGP policy to take advantage of all of these multiple connections. This is where you start to look at BGP as your solution. Again, if all we have is a single way out, we really don't need the BGP configuration overhead that would be required for Acme 1. And again, there's not a lot going on in the BGP configuration, but what if you're a small shop like this and you don't have a bunch of people who understand BGP, right? Or who are going to understand how to troubleshoot BGP. So this is a great use case for a single static default route. But I digress. Let's go back to the activity at hand. Again, where we're configuring things. This is where you see 4 here. We haven't really received 4. You may look up here and say, wait, I only see 2. And again, it's Packet Tracer, and Packet Tracer's thinking ahead, knowing that the activity in the end is going to result in us seeing 4 BGP learned routes. I believe that's what we're going to see when we're coming over to other company. So it still doesn't work. We still don't have a route to get there. Configure eBGP for other companies. So let's pull up other companies' router here. And again, right, kind of ironic that we're saying this is some other company, and we talk about the autonomous system being under our control, and yet here we are configuring this other company's network. So we're going to configure their network. Again, they're not, okay, so their network administrator's not familiar with BGP, and so we're going to give them some assistance. So we're going to configure their router to form an eBGP adjacency with ISP entry 2, which is their border router. I'm just reading the information here real quick. So let's get into global config. Whoops. Control-Shift-6 to get out of that. Let's get into global config. And our ISP, we're going to say do show run. Let's see if we have anything yet here. And we're going to say section router BGP. So no BGP yet. So BGP, router BGP 65002. So we could say BGP log neighbor changes, right? Always good. More information is better, right? When we're thinking about, hey, I need to see what's going on. So BGP router ID, and we'll set that to, this is, what is their other company? We'll say 1.1.1.10, right? Okay, so we're going to do our neighbor statement here, and it's going to be 1.1.1.9, right? That's /30 that we share between each other. As the neighbor IP address, and their remote AS is 65003, and you can see the adjacency comes up right away. But what we haven't done is we haven't originated the network to which the Acme network needs reachability. The network layer, that layer 3, the network layer, IP reachability information, we haven't originated that yet. So let's go ahead and do that with a network statement for the 172.16.10.0. And again, remember, we're talking about the network we're advertising here. Now, if it was a /16, we could go ahead and hit enter right there, but it's not. It's a /24. And this is a case where that network, if I hit enter right here, that network is not going to be originated, advertised. Not going to happen. Because what is the classful subnet mask for a 172.16 or 172? It's a class B, it's a /16, but we have subnetted it to a 24. So I have to have the mask on there. So we're going to go from 83%, my guess is, to the 100%. And that's great, right? Again, super that we get the 100%. However, we've got a little bit more to discuss here. So now I should be able to go ahead and save my config with the right mem. And let's say show IP route. And what do you see here? We have 3 BGP learned routes. We see the 2 /30s, the transit segments. But then we also see that network that we desperately need reachability information to get to. Again, I could have solved this with a default static route on Acme 1 and a default static route on other company. And then, again, the ISPs would need some work to be done as well, but that would have allowed what we wanted to have happen. But we're doing it through BGP. So we see that advertisement. And then I'm going to say, and actually we're not going to ping from here. It's going to want us to verify that Acme formed the adjacency, and it did. We said show IP BGP summary, and here you can see this information. And if I was to do the same thing here on other company, show IP BGP summary, we would see that same information that, hey, we've got a peering. And again, it's showing prefixes received as 4, even though we've only received 3. So now we looked at the routing tables, and let's look at the routing table here. So we should now see show IP route. And this is very important. Keep in mind, the BGP routing table, if I say show IP BGP, that is the BGP routing table. It is mutually exclusive in terms of the information it contains. It's totally separate from the RIB, the routing information database that I see when I say show IP route. Those are totally different, right? Totally different. So I say show IP route, and do I see that BGP route that I've learned now across the vast internet here? And yes, there it is. So what that means is now when I come down here to ping the 172.16.10.2, I go to my default gateway, Acme 1. Acme 1 then says, hey, I know how to get there. And it forwards the traffic on here, which then forwards the traffic here. And now it knows how to get to the other company 1 because other company 1 is advertising that NLRI, that network layer reachability information for the 172.16.10.2 network. So we looked at the routing tables. We see all the information. Open a web browser, and any Acme Inc. device can I get to, that web server. So let's pull up the web browser, and let's go ahead and say 172.16.10.2, and there it is. Let's take a look at the copyright information, right? All that great Cisco copyright information. And from any device, and again, we could pull the laptop up so that we're using some other device here, 172.16.10.2, and it works. And so again, that's it for the activity. We need to talk about a few other things. Remember, BGP is a path, it's classified as a path vector routing protocol. It's all driven off the autonomous system path. And if over here on Acme 1, I was to say show IP BGP, you can see that over here on the far right-hand side, we have the AS path. Now, again, we're only going through one autonomous system, but this is why it is referred to as a path vector routing protocol, or classified as a path vector routing protocol, is it's driven on the AS path. And we talked about the attributes. Now I'm going to show you a few additional resources that I would highly, highly recommend you take a look at. The first is going to be this document, which is an amazing document. And if you were to simply Google BGP path attributes Cisco, you would find this document. And one of the first things I want to talk about is paths that are ignored by BGP, because sometimes BGP will receive a route in NLRI and it will ignore it. It won't install it into the RIB. And take a look right here. Paths for which the next hop is inaccessible, right? So next hop is a BGP attribute. And so if the next hop address, I can't resolve it, I don't have reachability information to get there, it's going to be marked as inaccessible, right? Or I shouldn't say marked as inaccessible. It's going to be inaccessible. That route that has a next hop that I don't know how to get to, I can't install that route. And here's where the conversation with BGP transitions to BGP as a routing protocol, or is BGP really just a policy application tool? And again, no one is going to ever say that, oh, BGP is not a routing protocol. But when we peel back the layers of the BGP onion, we start to see that BGP is dependent upon the IGPs. And read the statement right here. Be sure that there is an interior gateway protocol route to the next hop that's associated with the path. Because if the IGPs, and here's where we go full circle back to when I said directly connected, think of it like a routing protocol. That's exactly what's happening here in the lab that we're working on right now. Directly connected is looked at as an IGP from the next hop perspective. So BGP is dependent upon the IGPs for next hop resolution for the next hop address. So if on this router, Acme 1, I get a BGP update that comes in, and that update is for the 172.16.10, and it has a next hop value that I don't have an address, that I don't have a route to get to. I don't have a routing protocol telling me how to get to this next hop address. I'm not installing that route in the routing table. Full stop. That's it. Right? And so how is it that Acme knows about the next hop to the ISP? Yeah, it's directly connected to it. If I say, and actually we have it right here, don't even need to say it, do I know how to get to the 111.1 for ISP entry 1? Yeah, I'm directly connected to that network through my serial 000 interface. This is how the next hop is sorted out with this example right here. If I didn't know how to get there through directly connected, and again, when we get into internal iBGP, that's where we start to talk about OSPF or IS to IS providing that next hop reachability information, right? Here with eBGP, it's typically that you're directly connected, but that might not be the case always. So in this use case, that is how the next hop information is sorted out. And take a look, because it's here that you're going to see 3 of what are referred to as BGP mandatory attributes that are mandatory, that have to be in every BGP update that you get. You have to have the next hop. And again, this is a standard. So if I go back, and a standard in terms of BGP implementations, again, if I go back to, I'm sorry, not here. I wanted to see the RFC. If we come back to the RFC, and let me clear the screen, and we scroll down just a little bit, you can see path attribute usage. So let's go to the origin, right? It is a well-known mandatory attribute. The origin attribute is generated by the speaker that originates the associated routing information. Should not be changed by any, so you have to have the origin in an update. If we go back here, here is the origin over here on the right. Now, you'll notice you see this question mark and the I and the I and the question mark. So these all mean something, right? But again, look right here. There are your origin codes. I means I learned about it from an IGP speaker, right? That it was IGPs allowing me to get this route. If it's an E, it would be EGP. And the funny thing is that EGP, again, the routing protocol doesn't exist. The question mark means it's incomplete, meaning I don't know how it was originated. If it was I, it means that the BGP process originated it with a network statement, and it was IGP information. And so when we look at the 172.16.10, you get this question mark right here, meaning incomplete. Even though we originated it with a network statement, we don't see that. And again, this could be packet tracer doing its thing. And we see this route here. When you see the quad zeros for the next hop, it means it was locally originated. It means there is no next hop, that I am the next hop. And so origin is mandatory. Next hop is mandatory. AS path is mandatory. So those 3 path attributes, the origin code, the AS path, again, well-known mandatory, come down here to next hop, well-known mandatory, right? We have to have that information in the update, or else it will not be, if this information is not in the update's not even going to be accepted. If the update has a next hop that I don't know how to get to, then Acme 1 would not install that routing information. And so we talk about those path attributes. Next hop is critical, and that is why you'll hear some people, first time I heard this was probably 15, 20 years ago. Brian McGahan at Internet Working Experts referred to BGP, it's the first time I heard it, as just simply, it's a policy application. It allows you to implement policy. It's really not doing the routing. The routing is all about sort of the IGPs along the way, because for the next hop to work, you have to have IGP information that gives you that next hop reachability. So let's skip by that. So here's how the algorithm works. And this is where BGP gets very confusing very fast. Because if I receive multiple pathways to get to NLRI, to a prefix, to a route, how do I choose which is better? Well, the first is going to be based off the weight. Next, I look at another. And again, a quick note on weight. It is a Cisco-specific parameter. Now, you'll notice they don't say Cisco proprietary because it is not proprietary. If you go onto a Juniper router, weight is an option. And Juniper is smart. They know Cisco implements weight, so they have it on their platform. It's Cisco-specific. And more importantly, what this means is that this is not advertised into BGP, right? Weight is not, it's locally significant, and it's one way that you can control the outbound flow of traffic. And we'll talk more about control versus trying to influence. Remember, autonomous system, you have full control. If you had multiple connections to multiple service providers, you have full control over how your traffic leaves your autonomous system. Weight is one way to control that. Local preference is another way to control that. And now we're talking about applying BGP policy to control the flow of traffic. So where don't you have full control over the flow of traffic? Well, that would be traffic coming to you from another autonomous system. Remember, autonomous system by definition means you have full control over that autonomous system. If it's an autonomous system that you don't, guess what? Once your traffic hits that other autonomous system, you have no control over how that traffic is going to exit their autonomous system, the other autonomous system. And you have no control over how the traffic is going to come back into your autonomous system. You can try to influence how that's going to work, and you can do that with the AS path attribute as well as the MED, Multi-Exit Discriminator attribute. And now you start to see how BGP gets really complicated. Now, in reality, if you're connecting to multiple ISPs, you will be negotiating through the service provider agreement whether or not they adhere to or care about the AS path prepending that you're doing. If they say, yeah, we'll allow you to do AS path prepending, then you can certainly influence, right, the return traffic, how traffic is going to come back through them to you, right? MED, Multi-Exit Discriminator, this is a tricky one because MED is only as good as the next autonomous system that it's going to hit. Meaning if you're trying to influence how traffic from an AS 5 AS hops away is going to come back to you, MED isn't going to help you, right? And again, AS path, and we look at these in terms of which ones are the ones you would use, it depends on the use case, right? AS path, remember, that is a mandatory well-known attribute, meaning 10 autonomous systems away, they're going to care about AS path and getting back to you, and when they go to return to get back to you. That's going to make a difference. And the shorter the autonomous system path, the better. Meaning if I'm prepending, adding instances of my AS path through BGP policy to make one path look less preferable than another path, AS path might be the way to go. If I only care about how my immediate neighbor is going to be doing things, then maybe MED is the way to go. So again, as you can see, it goes down, I think it's like 13 or 14 different things that, and this is how BGP will determine which path is the best. It's going to look and see, is the weight defined, right? For Cisco. Is the weight defined? No. Is local preference defined? No. Was the path locally originated via a network or an aggregate command? No. What about the AS path? And again, some of these things might tie. The AS path could be the same length. Well, then I've got to go down and take a look at the origin code here. Is it eBGP? Is it incomplete? Like what is that set to? Prefer the path with the lowest MED. And again, MED gets really tricky. So BGP is all about policy, right? It's all about policy. So this document, again, if you just Google Cisco BGP Best Path Selection PDF, you'll find this document. And the final resources that I want to leave you with are 2 books. Now, as a UMGC learner, you have access to this for free. The Safari Books Online, which I think they've renamed to O'Reilly. And all you would have to come in here and do is search for those books. TCP/IP. Here's volume 1. Now you're looking for volume 2, but you're looking for the 2nd edition. And this book is written by a gentleman by the name of Jeff Doyle, and he is a legend in the Cisco Press author space. And his texts, volume 1 and volume 2 on routing TCP/IP, are legendary. And the 2nd edition right here, which focuses on BGP, and let's see if we can get the, I was going to hope to get the table of contents, title page. Where is the table of contents in here? I actually don't see the table of contents. I may be going right by it. But again, just looking here, right, if we look at this as the table of contents, introduction to BGP, BGP and NLRI, BGP and routing policy, scaling. I mean, this is the definitive text on BGP. In terms of troubleshooting BGP, Vinit Jain and Brad Edgeworth, again, 2 prolific authors with Cisco Press, you have free access to this book if you didn't want to buy it right here in the Safari online library. If I was to go back home and say troubleshooting BGP and just search for it, there it is, right? And they've got live lessons as well. So if you are interested in watching videos, right, troubleshooting BGP, they have a live lessons that accompanies it. Again, video training, 7 hours worth on troubleshooting peering issues, platform issues, routing policy, like all these things that you want, if you wanted to learn about, you can learn about. All right. Well, I've given you a ton of additional resources to think about here in your discovery and your inquiry into BGP. So that is going to do it for this activity. Again, the activity's the activity. More importantly is additional resources for you to continue to grow your skill set with BGP. So thank you so much for watching, and I hope to see you in the next video.